Okay, I think we'll get going. So a very warm welcome to our Autism at Manchester 2020 webinar series. Thanks so much for joining us today. I'm Cathy Ledbetter and I'm the events coordinator for Autism at Manchester. In just a moment, I'm going to have the pleasure of handing you over to my colleague Dan Poole, who's going to talk to us today about time perception and autism. Which I can assure you is an absolutely fascinating topic. But just before I hand over to Dan, there's just a couple of bits and bobs that I'd like to run through quickly. So firstly, just a brief introduction to the Autism at Manchester network. So we're a community of academics, students, professionals, autistic people, family members and other stakeholders. And our key aims are to achieve quality research with a real meaning for autistic people and to share knowledge and understanding around autism research, and also to collaborate together on the selection, design and conduct of research. So I would really encourage you and invite you to connect with us via our website, and the web address is here, where you can find out much more about our work. You can also find out on the website how to sign up to our mailing list. And you can also connect with us via our social media accounts. We're on Facebook as Autism at Manchester and also on Twitter as Autism at Manchester too. I'd also like to take the opportunity just to do a little mini plug for our future webinars. So we're having a webinar again next week, same time, same place. And that is will be presented by myself and some of my colleagues, and we'll be talking about the development and piloting of a post-diagnostic programme for parents of children recently diagnosed with autism. And then the following week, on the 20th of October, also at the same time and in the same place, we'll be having two talks on the topic of language and communication development in autism. So all these promise to be really interesting talks. You can use the same link that you've used today to access these webinars, or you can go via the Eventbrite again, or you can just sign into the Autism at Manchester YouTube channel and find us there. So just a couple of little housekeeping things. So we encourage you to post your questions in the YouTube chat. I will be able to access them there and I can present those to Dan at the end of his talk. Just to say, if you do have any burning questions, please make sure you get those up nice and promptly so that I can see them in time. And also because there is a little bit of a delay between us giving a presentation on Zoom and what you can see in YouTube. So do get your questions up there. We look forward to them. Also, just to point out as well that the webinar will be left up on YouTube after the event, and it will also be linked to from the Autism at Manchester website. So, you know, you're very welcome to share the link to friends or family who might be interested. Please do share it and people can access it at any point after the event. Okay, so now to introduce Dan Poole, I'm just going to stop sharing my screen so that Dan can get his slides up whilst I'm giving him a little introduction. So Dan has been at the University of Manchester since 2011. He did his PhD at the University of Manchester and he's currently in a postdoctoral position, which is a collaboration between the Body, Eyes and Movement Lab, which is co-directed by Emma Gowan and Ellen Poliakoff, and the Time Perception Lab, which is headed by Luke Jones. And his work is funded by the Economic and Social Research Council. Dan's research focus is on perception and attention in autism as a route to understanding the cognitive mechanisms underlying sensory difference. And he's also very interested in improving autistic people's experiences of research. So welcome, Dan. I'll hand over to you. We look forward to your talk.
Okay, thank you very much for that, Cathy. Much appreciated. And thank you everyone as well for tuning in this afternoon. So the work that I'm going to be presenting now is part of a larger project, as Cathy's mentioned, that's funded by the ESRC, called the Autism Timing Study. So what is time? This seems like a relatively straightforward question, but it's not very straightforward to answer. And I think you'd get a very different response if you ask this question to a philosopher, a physicist, a neuroscientist. I'm not going to attempt to address this today, but what I just want to start off with is just getting you to think a little bit about some of the ways in which timing shapes our everyday behaviour and a lot of how we think and act. So the first example would be in terms of simply how we perceive the world around us. We're constantly receiving information from a variety of different sensory sources, from vision, touch, hearing, smell, so on. These all reach your brain at slightly different moments in time. And yet our brains do a fantastic job generally of creating a clear and this rich perceptual world that we exist in. Also, in terms of how we move, timing is very important. So if we think of something relatively straightforward form of movement, such as walking, such as shown in this point light display in the bottom left corner, we have to carefully or we automatically synchronize our movements from each step that we make so that we're able to stand up and retain our balance. And also we have to combine the timing of our movements with our incoming sensory information. So if we need to change our course, if there's obstacles in our way. So the walkings are relatively straightforward in terms of movement control, but also more complicated behaviors such as how we interact socially have a strong timing component. So if you look at this point light display, the way this person is gesturing, and then how we combine our gestures in time with our speech is very important in how we interact. Also when we're actually interacting with someone, the smooth cadence of our discussion, the back and forth and timing our interaction so that we don't constantly interrupt each other. So all these types of timing that I've just mentioned are things that we do unconsciously all the time. We don't think about doing them. But human beings also have a great capacity to think about time in quite an abstract sort of way. From a very early age, we begin to be able to reflect on our past and also to increasingly think ahead and plan for our future. And also we can think of time on quite different scales, including thinking about times in which we have never existed ourselves or futures in which we won't continue to exist. Really, I'd say timing is something, and time is something that human beings are quite obsessed with. And this is reflected in a study from a few years ago, which looked at a number of different written sources and found that time is actually the most used noun in the English language. We're obsessed with time. Okay, so I'm just going to move on to something now just to really illustrate this point about how our brain is very expert at processing time. What I'm going to do is present two beeps to you back to back, and I just want you to think about which one you think is longer than the other. So this isn't a very controlled experiment. We're doing it through this presentation, so don't worry if you don't want to take part or you find it too difficult to do, just to illustrate this point. Okay, so here's the first beep. And is this longer than B? Okay, so which one's longer, A or B? So I'll just play those again one more time because they're quite brief. So here's A, and here's B. Which one of those was longer? If you said A, you would have been correct there. A was a mere 150 milliseconds longer than tone B. So just for some context, 1 second is 1,000 milliseconds. So this is an incredibly small amount of time that our brain is able to, perhaps many of you found quite easy there, to unpick which one was longer than the other. I'm going to give you another example now, which is a little bit briefer and a little bit more challenging. Okay, so it's exactly the same again. Which one is longer? It's A and now B. Okay, and I'll play them again for you. Okay, so perhaps you found that one a little bit more difficult, but perhaps you were able to, some of you may have been able to do it and found that B was longer than A on that one. In that instance, it was a mere 50 milliseconds longer than A. So for those of you who could do it, you would be able to discriminate times at the rate of a mere 1/40th of a second. Again, a really incredibly small unit of time. So what was that? What did I just ask you to do? This was an example of a psychophysics experiment that we might do in the lab. So perhaps many of you haven't really come across this before. Psychophysics is a subdiscipline of experimental psychology, and it's concerned with the relationship between physics side of things, physical stimuli such as sound pressure, light waves, and so on, and how these are converted into our psychological experiences, this perception of this rich perceptual world around us. Now, the challenge in psychophysics is that the thing that we want to measure, which is perception, is something that's generated in the mind. It's not something we can tap into and measure directly. Psychophysics is a very empirical science, and what we do as psychophysicists is that we manipulate, we have something that we can manipulate, which are stimuli, and we can systematically vary those, and then we've got something that we can measure, which is a person's response to those stimuli. So we can measure individuals' varying responses to those stimuli. What we can then do is generate theories and models about what might be happening in those psychological perceptual processes that can then be tested and explored in different contexts. So in the context of time, what we would do in a psychophysics study is we present stimuli of varying durations, and then we measure an individual's responses to those durations and start to develop models and ideas about what might be happening psychologically, how their timing systems are functioning. So currently, still the major model of timing, psychological timing, is called scalar expectancy theory. Now, in a real nutshell, the idea behind scalar expectancy theory is that your brain does something much like a clock when keeping track of time. So it's called an internal clock model of timing. So all clocks have, central to them, have a pacemaker. So old-fashioned grandfather clocks had something, had pendulums which kept pace, something that was providing this routine, regular event, providing tick, tick, tick. More modern watches use vibrations of quartz crystals. And much like this, under scalar expectancy theory, we have a pacemaker. In this instance, it's the fluctuations of activity in our brain. It's just going on constantly. Then, if we decide we want to pay attention to time, we want to be aware of how long something is, we pay attention to time. This then leads to the closing of a switch. And while that switch is closed, so for instance, if we decide in a psychophysics study we want to pay attention to how long a beep is, or in real life, if we're just stood waiting at the side of the road, we've pressed the button and waiting for the green man to pop up, we're waiting for something, we accumulate ticks from this pacemaker. So in this instance here, whilst the beep is happening, we accumulate 3 ticks. And then this information is moved down to what's referred to as working memory. This is where we hold information in mind that can then be acted upon later. And then we can compare this to previous representations of time that we have. So again, in the context of a psychophysics study, we may earlier on have heard a beep that was 5 ticks, and we compare this to 3 and say the first one was longer. In a real life context, we might be waiting at the side of the road and have a representation of how long does it normally take to wait. And you have that feeling of whether some crossings feel like they take longer than others. So that's scalar expectancy theory in a nutshell. It has these separable processes, clock, memory, and decision processes that can be measured and can be tested in different experimental ways. And also this model has a strong history at Manchester University. Professor John Weirden, who spent most of his career at Manchester, really did a lot of great work in shaping and testing this model. And also Dr. Luke Jones, who's the principal investigator on this project, has done a lot of work, important work in helping test and shape this theory. So this is a bit of an introduction to psychological timing, but we're interested in time in the context of autism. So perhaps many of you will be somewhat familiar with autism, but for those of you who are not, autism is a complex neurodevelopmental condition. Autism is quite common. By current estimates, it occurs in about 1 to 2% of the population. And diagnostically, autism is characterized by certain behaviors. So the diagnostic criteria include differences in social interaction and communication. So this could include understanding how to use how to use and understand non-verbal aspects of communication like eye contact and gesture. There's also what's referred to diagnostically as restricted repetitive patterns of behavior, which encompasses quite a few different things, including people having a strong adherence to routine or exhibiting what referred to as repetitive movements, and then also differences in how the senses work and overwhelming sensory experiences in certain contexts. But this diagnostic criteria doesn't really capture what autism is, and there are a wide variety of differences observed in autism. So some of those sensory experiences, it's a bit more complicated than just that people feel very overwhelmed. Many people gain pleasure from certain aspects of their sensory experiences, like this child here who seems to be enjoying the sound of his voice echoing through this tube. There's also differences in movement coordination. Increased clumsiness is reported in many autistic people. And autism really, my take is, it's a condition which fundamentally is a fundamental difference in how a person interacts with and experiences the world around them. It can present many challenges, but also it's an aspect of human diversity that brings a lot to the world. I just wanted to illustrate this autistic artists who, through the way that they perceive and interact with the world, this is shaped in their art. Now, another thing about autism being that it's very variable in terms of how autism presents in different people. And there's a lot of different theories and approaches that that researchers have to trying to better understand the condition and in order to better support autistic people and their families. So one theory that's been proposed is the so-called temporal deficit hypothesis of autism. Essentially, according to this theory, that autistic people have problems with fundamental timing processes, and that these problems with timing processes, as I mentioned earlier in the presentation, timing underlies a lot of what we do and how we interact with the world. These timing problems have an impact on these other aspects that we see in autism. So these are some headlines I've taken from Spectrum, which is a research digest of autism research news, somewhat over-emphatic headlines. There's also been pieces of research which suggest there's a general problem with timing in autism. And I've also come across, there's some work that seems to be ongoing at the moment, multi-center research, which is looking at how time experiences can be manipulated using virtual reality, and whether this can be used as a form of treatment for autistic people and in other neurodevelopmental conditions. So this all sounds very exciting and interesting. However, it's not quite so straightforward. So Martin Casasus, who is a PhD student who's been working with us on this project, completed a systematic review on the literature existing around time perception and autism. So a systematic review is where you get an entire picture of all the currently published research on a particular topic, bring it all together and try and synthesize it and make sense of what the current evidence base is and for future directions. So the first thing Martin found was that there's a wide variety of different approaches that have been used in studies which attempt to measure timing in autism. So Martin developed a taxonomy by which he attempted to characterize the work that had been done and look at the evidence base surrounding that work. So Martin, it was three levels that Martin devised. So there was timing sensitivity. So this is the sort of thing that we did at the beginning of the presentation, just looking at differences in low level sort of sensory information around timing. Then there was what I would broadly refer to here as SET type timing, scalar expectancy theory that we mentioned before, about the perception of duration. Then there's what we would refer to as higher level timing here, sort of more abstract reasoning, ways of thinking about time. So when you split the research base up like this, the work around timing sensitivity and SET is in fact actually pretty mixed, so not really supportive of this temporal deficit idea. There are some studies that do show differences in autistic people, but also others that show that they're the same as neurotypicals, and also some where autistic people outperform non-autistic people. The work that is out there, which is investigating higher level timing, is a little bit more consistent in showing that autistic people have some problems with timing, but there really aren't very many studies on that. So in the autism timing study, what we're aiming to do is develop a much better characterization of timing in autism, looking at these different timing across these different levels, so we can have a bit of a better picture of timing processes, and this could point to which mechanisms might be affected and how more effective support might be offered if it's needed. So in study one, we're looking at these higher level timing processes in a bit more depth. So background to this is there have been two pieces of research which have used questionnaires to look at timing processes in autistic people. I'll talk a little about this questionnaire in a minute. And this work showed large differences between autistic and non-autistic, which I'm going to be referring to as neurotypical groups. So very large differences. However, the work that had been done used very small samples. There weren't very many people in each group. And the problem with this is that it makes these estimates a little bit less reliable. So the aim of study one was to better characterize these behaviors related to time in everyday life, replicate this effect in a much larger sample, and also try and get a bit more detail about the nature of the issues that people were experiencing. So we recruited 113 parents of autistic children and 201 parents of neurotypical children. of children aged between 7 and 12. We chose this age bracket because this is a phase through which children do a lot of formal learning around time in school. The study was completed online, and our recruitment was supported by Autistica, who run a database for parents of autistic children. And so parents completed the It's About Time questionnaire. Now, this is a questionnaire that was developed for measuring timing in children with ADHD. It doesn't actually measure one single concept, but it can be broken down into measuring time management abilities, future and past thinking, and an individual's time concept. We also included some open-ended questions so we could get a bit more of a detailed insight from the parents in their own words about their children's timing behaviours. So this is the questionnaire data. It's possible many of you may not have seen data shown in this way. These are called rain cloud plots. These are quite trendy ways of displaying data at the moment, or at least as trendy as data visualization is likely to get. What's really useful about them is that we can see a lot of information very easily about the data, much more than you would see in a bar plot or just a box plot on its own. So what you can see is each dot is each individual. And then we also get a nice representation of the distribution of those individuals. The important thing to be looking for is how much these dots and these two distributions overlap with each other. And on these It's About Time scores, you can see the autistic group are much lower than the neurotypical group overall. So this really quite closely replicates the previously observed effect. So as I mentioned, we also included some open-ended questions so parents could write a little bit more about what they saw in their children. So the first thing to note was that parents did report quite a considerable impact of relating to timing in their children. They talked about quite a marked impact on the children's well-being and much increased sense of stress and anxiety relating to timing. So I'm just going to be showing with all of this some example quotes from our data set in italics. So what I'm going to show you now is the results of what's called thematic analysis. This is where we take this kind of data, which is called qualitative data, and we look for patterns and important themes. And this does involve a little bit of interpretation on our part around this very large amounts of qualitative data that we obtained. So the first theme was temporal knowledge. So the idea here, it seemed that parents of children in the autistic group were describing issues with how they learnt about concepts around time. So this involved telling time from the clocks, particularly analog clocks, and also appropriately using language around time, things like different units of time, like seconds, minutes, weeks, years. And perhaps as a consequence of this, there were different behaviours that were reported in terms of how timing was approached. So many parents talked about their children having an intense focus on time. So they didn't quite understand how time worked, but they were very worried and concerned about punctuality a lot of the time. On the other hand, there were some parents who reported their children as being completely avoidant of the whole of being on time for things or how timing might interact in their lives. The next theme was prospection. So this is the capacity to imagine and think about the future. And the parents talked about their children having problems with anticipating the future and flexibly adapting to what happens. The future is often not as we plan it. And then as the future occurs, if this is contrary to what our predictions about are, how we interact, how we respond to that. And as a means of ameliorating or dealing with some of these problems, parents talked about how they avoided overloading their children with multiple plans, so there was less they had to think about in the future. The final theme is monotropism. So this isn't our own idea. This comes from the work of autistic scholars, Dina Murray and colleagues. The idea, this is a theory of cognition in autism, which says that we all have limited cognitive resources, and in autism or autistic people focus those resources on a closed range of interests. So in the context of this study, this related to how children's behaviours at the time related to their and were shaped by their interests. Autistic children were described as viewing their time as highly precious, and time spent on any activities unrelated to their interests were wasted. They placed a high regard in punctuality in others and making sure they were on time for things. And interestingly, I thought that they showed, talked about their children having a high awareness of time when they were doing the things they were interested in. So they're talking about them monitoring time as best they could, so they could squeeze as much as they possibly could out of the things that they were interested in. Time itself also came up quite a lot as an interest. So recording the times of things and being interested in times in different countries. And so, but however, where timing was an interest, it didn't seem to lead to improvements in other areas related to timing behaviours, such as planning and thinking ahead. Okay, so in this study, we supported replicated the previous findings, and we also extended knowledge by pointing to these different areas, these key themes, which we hope will motivate future research and might start to point to ways in which we can support autistic children relating to timing. I should point out there are limitations of this survey. So because it was an online survey, we couldn't ask follow-up questions. So parents often wrote something that'd be quite interesting and we couldn't follow that up. So it'd be interesting in future work to do interviews, more detailed interviews with a smaller number of parents about what they're seeing in their children. And of course, the parents themselves only offer one perspective. It'd also be interesting to get the perspectives of teachers who work with children in the structures of a school day. And of course, the children themselves, the things that they find difficult and what's important to them. Okay. In study 2, this is in many ways the centerpiece of the project. And this is where we looked at all the different levels of timing that have been identified experimentally in adults to get a better perspective on timing processes in autism. So in this study, we recruited 57 autistic adults and 91 non-autistic controls. Participants were invited to the time perception lab at the university, and they completed a battery of testing. This involved a series of experimental tasks, questionnaires and other activities. The study was pre-registered. This means if you follow that link, we locked down online what we plan to do in this work. Because this work did involve face-to-face testing, so people had to come into the lab, we did have to stop a little bit early. The pandemic was really unfolding, and it was becoming apparent that it wasn't safe to continue testing. So we closed the study a little bit earlier than we planned, but we'd almost reached our recruitment goal. And I should point out, so there may well be some people here today who took part in the study. You might notice that there were many more tasks than what I'm going to be talking about now. You seem to do a lot more stuff. Particularly, I'm not going to be talking today about the visual timing tasks, but the story, the conclusions are much the same. So just to make things a little bit more straightforward to follow. So I'm going to talk through each task in turn now, just to introduce the tasks and what they told us. So So the first one I'm going to talk about is the time sensitivity task. And this task was measuring, as you might expect in this taxonomy, time sensitivity. Here the participant compares the duration of two very brief intervals. So this is much like the task I asked you to do at the beginning of the experiment. One of these was always 700 milliseconds. And then there was another tone that varied. It started out at 1,000 milliseconds and was adjusted using what's called a staircase. That's the duration of the other tone was adjusted according to a staircase. And so we could find the point, it was get progressively shorter and longer, so we can find the point at which the person could just about tell the difference between the two. So the smaller the amount of time, the smaller the person's threshold was, the more precise they are in their timing judgments. And what you can see here, there's no difference between the autistic group and the neurotypical group. They're really very similar in their performance on this task. The next task was the time estimation task. In this task, the participant is presented with a single duration, as it is again a tone, and they're asked to try and estimate how long they thought it was. The tones there was a variable number of tones between 75 and 1,250 milliseconds. And we took the average of the participants' estimates and fitted them to a regression. You don't need to worry too much about this. The key measure that we extracted from it was the slope, which is a measure of precision. So this task taps into the scalar expectancy, interval type timing, and particularly clock processes according to this framework. So here on the y-axis, we have those participant slopes. So a slope of 1 would be completely perfect performance on this task. And again, you can see here that the autistic and the neurotypical group, the data looks very similar. The two groups are performing in a very similar way. The next task is the time comparison task. In this task, the participant is asked to remember duration and is then asked to try and remember this. And then later they're asked if other durations are the same or different to the one that they tried to remember. We then use something called signal detection analysis to extract a measure of how sensitive, how precise participants were in their judgments. So this task is a standard task within the SET framework, and it taps into all the different components in SET. So clock memory, I've missed out here, but also decision making. So here, this is A prime. This is the measure of sensitivity. The larger the values are, the more precise the participant was in their estimates. And now it's not so clear here, but perhaps you can see that there's more neurotypical participants clustered near the top. And this comes out statistically that the autistic group were less precise on this task than neurotypicals. So I should say slightly less precise than neurotypicals. So this is when we introduced a memory component, the autistic group didn't perform quite as well as the neurotypicals. So does this just mean that memory maybe is affected? The ability to hold information in mind, and certainly there is previous work that has shown more broadly nothing to do with time, that working memory is different in autistic people. As it happened, we had another task which involved, it was exactly the same as the time estimation task, but it measured, the judgment was related to pitch rather than, and had nothing to do with time. What we found here, there was no differences between the groups. The autistic group were in fact slightly more precise in their judgments. So this suggests that it's not just a problem with time here. There could be something about how autistic people were holding information about duration in their working memory. So the next task, it's a little bit different. This didn't involve making judgments about beeps, and it's referred to as retrospective judgment. So in the time lab, the time lab is in the basement, and it's in a windowless room in a very quiet corridor. There's not much information about time in there. And when the participants arrived, we asked them to put their watch or their phone in a basket, just to really remove that sense of time. I spent many hours in there, and I can really attest that when I came out, I'd frequently be completely confused by what time of day it was. But this also provided a helpful marker for us. So what we did is that a very specified point in the testing procedure, we asked the participant, how long has passed since I took your phone or watch off you? This, on average, was around 52 minutes. And this is actually a standard experimental task. It's a bit more difficult to categorize. Perhaps it's an abstract, higher level task. Perhaps it's an SET type task because it's tapping into duration. So this is the participants' retrospective judgment. So because it was different for everyone, I've calculated this as a proportion. So if the participant was absolutely bang on accurate, this measure would come out at 0. If they underestimated, it would be negative. So they thought the amount of time that passed was less than it actually had. And if it was positive, they were overestimating. So the first thing that's interesting to me is that people tended to underestimate the amount of time. So even though people were sitting through this not exactly exciting battery of psychophysical tasks, they tended to think less time had passed than actually had. Time was flying for them. But importantly, there's no differences between the autistic and neurotypical groups here. Finally, we also took some questionnaire measures as well. So there's the It's About Time questionnaire that we talked about earlier, adapted from the caregiver questionnaire for adults to respond to. Just to remind you, it measures sense of time, punctuality, and ability to meet deadlines. And we also took another questionnaire. This is the time structure questionnaire. This measures something referred to as time structure. This questionnaire comes from the management literature and is tapping into a sense of purpose, how you structure your time, how you get the most out of the time in your day. So firstly, looking at the It's About Time scores, we again see, so it's very similar to the work that we've done in children, that scores were reduced in the autistic group compared to the neurotypical group, and this comes out statistically. But the effect is much smaller than it was in the children. You see much more overlap here between the groups. However, the story was different on the time structure questionnaire, where there was the autistic group actually produced higher scores on this questionnaire measure of time structure, while the neurotypical group were a little lower. So it's a small difference, but it was also statistically came through. So it doesn't seem that abstract reasoning about time is necessarily worse in autism, as has been predicted by this temporal deficit hypothesis. It's different between autistic and neurotypicals. So just to summarise study 2, we observed these differences on these questionnaire measures. So attempt to bring this idea together, it seemed that what these participants were reporting were they had more issue, the participants in the autistic group had more issues with managing their time and reaching deadlines and thinking about the future, but also perhaps got more out of their time on a daily basis, had better structure to their days. So we also found there's this effect that perhaps the ability to hold information about time in mind might be impacted in autism, and this certainly looks interesting and might warrant some further investigation. And but perhaps most importantly as well is that the time sensitivity and clock processes, we just didn't observe any differences between the autistic and the neurotypical group. Overall, the data in this study didn't support the temporal deficit hypothesis, the idea that there's a general timing problem in autism. So providing a summary really of the study as a whole and where we're at this point. So as I said, the sort of basic timing sensitivity doesn't seem to be adding to the existing literature. Our study suggested there doesn't seem to be a difference in basic timing sensitivity. When we look at SET, the sort of duration type judgments, that perhaps there's no difference in clock processes relating to duration, but the picture might be a little bit more complicated, that there might be something about holding time in mind, in memory in autistic groups. But we have also added to the existing work that aspects of higher level timing processes may be impacted. So I'd just like to say thank you to the study team. So Dr. Luke Jones, who was the principal investigator on this project, Dr. Emma Gowan, Dr. Ellen Polyakov, also Dr. Martin Casasus. And I want to particularly thank Martin. He and I work quite closely together on the data collection in study 2. I neglected to say before, but I would also like to say thank you to the Autism at Manchester expert group, to the virtual group, who provided a lot of really helpful input into the design of this study 1. And then also, most importantly, a huge thank you to all the study participants, everyone who gave time to this research. It wouldn't have been possible without them. And thank you to you all for listening to me.
Thank you so much, Dan. Thank you. That's just a fascinating talk and just brilliant research that you've been involved with. And, you know, as a neurotypical person, I just don't think about time perception at all from one day to the next. So, you know, and it's just really interesting to hear about, you know, the impact that differences in time perception can have on kind of day-to-day functioning. And that's clear from some of the quotes that you shared from parents. And it's also been clear from some of the comments that have been made in the YouTube chat as well, where people have been discussing the impact of this sort of thing. And yeah, you've set up some fabulous experiments, really, really nice. So thank you so much.
Thank you, Kathy.
No problem, no problem. And we've got quite a lot of questions, so I'll move straight over to those. I've been trying to keep an eye on them. So just thinking where to start. So a question from Roslyn. Would all people with working memory deficits struggle to perceive time?
That's a good question. There's probably no straightforward answer to that. So it probably depends. Working memory for time, working memory is a generalized concept, of how we hold information in our minds. It's probably very domain specific. So perhaps if working memory for time was impacted, it'd be very difficult to, if we didn't have it whatsoever, we wouldn't be able to hold information about periods of time in mind. It's hard to construe what that might be like. However, if we had problems of working memory in some other area, so remembering where things are in space around us and things like that, that might not have an impact on our ability to hold timing information in mind. However, I should point out perhaps that, look, the expectation here wouldn't be that the participants in the autistic group don't have this capacity at all. It's different to the neurotypical group. People could do this task in the autistic group, just not quite to the same levels.
Okay, great, thank you. Thanks for that. Another question is more about kind of language, so language about time. And this is a question from Alison, and she asks, how many of these difficulties can be linked to some of the language concepts that support the understanding of time?
That's a fascinating question, and I think it's probably likely to have a very, very large impact, particularly in what the parents were describing, and it could certainly relate to language issues, to how the children were talking about time, talking about their futures, and so on. I think that would be a really interesting thing to look at in some more depth, for sure.
It would definitely be interesting to link in some of your work with some some kind of work around, yeah, those linguistic concepts and so on, wouldn't it? I totally agree. Okay, another question from Seb. How does monotropism, which obviously you talked about in your introduction, how does that differ to when someone who's neurotypical might say, time flies when you're having fun?
Okay, that's a good question. So that, like, and perhaps one of the interesting things that came out of that side of the of that qualitative data related to that exact point. So the constructs of like saying time flies when you're having fun, it implies that time just slips away. You're just in this moment, perhaps in a state of flow. You don't think about time. Then you look at it later and realize you were doing that activity for much longer than you expected. That's what, and in line with that, the monotropic idea, you would expect that people would be in that state when engaged in their interests, perhaps more frequently. And the parents talked about their children being very, very engaged in interests, as I talked about, and their timing really being shaped by that. But that point that I made, which seems to come out in the data, where the autistic children were doing something that was almost like the opposite of time flying when they were having fun. They were engaged in their preferred activity and actually monitoring the time. They were very aware of the time and were trying to squeeze as much as they could out of it. It was just, that was something that was surprising and I thought was really interesting.
Great, thank you. Thanks, Dan. And thanks everyone for all the questions, by the way. You know, fantastic questions that are coming through. So one from Marianthe, who's asked, I wonder how much role, what kind of a role routine plays in the perception of time. So you said, Dan, that the tasks were mundane, but participating in the study itself was an irregularity in people's lives and routines.
Yes, absolutely. So the role that routine plays. So I think within the original construction of this idea that there's a timing deficit in autism, the researchers suggested that that adherence to routine could be in part coming about because of fundamental timing problems. So if you don't have a strong intuitive concept of time and understanding of the flow of time, that then you might turn to routine as a means of helping structure that. So if your day becomes more structured and you've got more routine, you know, it's less important if you're the intuitive sense of the flow of time. So it's certainly, that link has been proposed. In terms of how the disruptions of people's regular routines may have impacted in the study, I mean, I suppose perhaps it could have impacted how people perform, but then the fact that we didn't see so many differences on those experimental tasks would suggest that the disruptions to the routine, they weren't producing something much different to the neurotypicals who in theory wouldn't have experienced such issues with disruptions to their routine. So it wasn't really there in the data.
Okay, and that links me quite nicely onto a question that I've got, which is, how do you think performance on the experimental tasks, so you know, focusing on these very small time scales, how do you think that relates to the types of timing in everyday life, you know, the types of things that are being picked up by these questionnaire measures?
Yes, that's a really interesting question. And it's something that we're hoping to address with the data from this study, because we've got all these different timing measures. We also have these questionnaire measures, and we also have these other measures around everyday, people's everyday experiences. We can try and start looking beyond just saying, are there differences between the autistic group and the neurotypical group, but looking at it in a more dimensional way. how do these relate to each other? And which tasks relate to which aspects of everyday timing? So that's something that we'd like to look at more for sure.
Okay, thank you. And we've had two kind of similar questions, which are around kind of interventions or supports. So whether it's kind of a therapeutic intervention for those who have reported problems with time perception, or whether there are any kind of tools or strategies or apps or things that can address some of these difficulties and differences that people are describing.
I think that's like the really important question, and I think what we've done here, and particularly that qualitative data, is we're really starting to establish that these are problems for people, and it's drilling down into what the mechanisms are which are affected in terms of actually then being able to offer the sorts of interventions and support that will actually really help people. That's also the sort of thing that we'd like to look at following on from some of this work. I think there's descriptions from parents around the anxieties and the stress that's being caused by time and issues around timing. So how to work with the families as a whole in sort of managing those pressures that come from the outside world with regard to timing, and improving that timing in these children. So what's best to do, I'm not sure. Again, this is perhaps another aspect of future direction that would be good to establish. It would also be great if we could do this sort of study that we've done in adults and described in study 2, bring that over to the sort of groups we're looking at in study 1 in children, and try and see, are these basic timing mechanisms impacted? Because it could well be that they are in children, and by adulthood it's just people have found compensation strategies, or it's just developed out or something, and that would be another gap in our knowledge that would be helpful to fill.
Sure. And do you or any of your colleagues have plans to kind of take this research forward to any kind of next steps that you're planning?
Yes, so the study is still ongoing at the moment. So we have some other studies that we're actually actively working on at the moment. So as you mentioned, Kathy, at the beginning, I'm particularly interested in sensory processing, and so we're doing some work around really looking in a bit more depth about how timing impacts on sensory processing. We're also doing some work looking at movement timing as well, really just specifically looking at how important timing is and how people move. But then beyond that, we've got a lot of ideas, and we're really interested as well. It's really good to have these sort of forums to hear from people from the autistic community about what are the things that people are having issues with, and allowing that to help us shape what we might be doing with our next steps. So yeah, we'd really appreciate any comments on people's own lived experiences.
Okay, thank you, Dan. And I think you said earlier that you're happy for people to email you if they have any specific questions, or if they want to contribute to some of that discussion.
Yes, absolutely, yes. If people, so if anyone thinks of a question after this session is finished, they have some more time to process this information, please feel free to email me, or yes, if you have any comments on this. So my email address is daniel.poole@manchester.ac.uk. I may not reply immediately, we're all very busy at the moment, but I would appreciate that information, and I'll get back to you as soon as I can.
Great, excellent. Well, I'm just conscious of the time. I bet you're just sick of people saying that, aren't you, Dan? But it is 6 o'clock, so we should probably draw things to a close. But I just want to say thank you to Dan for a wonderful presentation and for all the excellent research that he's doing into this area. And thank you to you all for attending the webinar today, and for your wonderful chat, and for all your excellent questions as well. Really hope you've enjoyed it, and hope you're able to join us again next week for our next webinar.